Okay, so here we are on the second batch, second 10. There's a total of 30 math questions. You won't get that many on your technician license test, of course. They only pick 4 or 5. Actually, the reality, and this may be true for all 3 levels, you can skip the math questions and still get a passing score. I don't recommend that you do that. I mean, that kind of defeats the purpose of kind of getting into the hobby. And if you're really not crazy about math or you're shaky on math, then please review my refresher videos or look at Khan Academy online or some of those places that are free and, take a little bit of math. Okay, so let's get to this. Which decibel value represents a power increase from 20 watts to 200 watts? That's a tenfold increase. Remember that this is logarithmic. So if I have some value here on logarithmic, the next one over is 10 times that amount. So things jump by tens and they get crunched up toward the end. It's like the Richter scale for earthquakes. If I had 7 on the Richter scale, that's 100 times, no, not 100, that's 10 times worse than 6 on the Richter scale. Goes up by tenfold. Okay. And your hearing, by the way, is logarithmic. You don't hear in a linear fashion. I don't know if you knew that or not. And they theorize that because we need our hearing for survival, we need to be able to hear really faint sounds as well as really loud ones. And so our hearing is logarithmic. I didn't know that until a year or two ago. That's new for me. Okay, so our answer here then is A, which is equal to 28,400 kilohertz. And they're giving us megahertz. It's not going to be 28.400. That'd be a lot less. It's not going to be 2.8 megahertz. We need that 400 in there. That's part of it. So that helps filter this out. Well, this is kilohertz, and a decimal point is going to come over by 3. So that's going to give us 28.400 megahertz. So D is our correct answer there. Most of these questions have to do with moving the decimal point around, so get good at that. All right, which is equal to 2425 megahertz, and they are giving us gigahertz, which is another step up from megahertz. So it's going to be something less, and I'm thinking if we come over another 1,000, put a decimal point there, it's going to be 2.4 gigahertz. Okay. That's interesting that I get this mark in here. That's because I have these. The printed version of these are in a Word document, and I just pasted them as they were onto my drawing program here, and I'm sure that was supposed to be an asterisk. It's kind of funny with that dark circle around it. It's a rather large asterisk. But that indeed is correct because power is equal to the current times the voltage. Remember, E is the traditional letter for voltage, electromotive force. Okay. It's more common nowadays to see V for voltage, but it wasn't traditionally. V was already used to stand for valves, which was the English name for radio tubes. Okay. How much power is delivered by a voltage of 3.8 volts and a current of 10 amps? Okay, so they're asking how much power it is, so that's our P is equal to I times E, let's just fill that in. So power then is equal to a current of 10 amps times 13.8 volts. 10 times any number just moves the decimal point over to the right one, so to the right by one. So this is going to be 138, what are we looking for? Watts. And that is answer A. How much power is delivered by a voltage of 12 volts and 2.5 amps? Same problem, same type. P equals IE. I always like to start with the formula that I'm going to be using to make sure I'm getting it right. Okay, and then just fill in the values. So P then is equal to a current of 2.5 times 12 volts. And I'm going to do that on the calculator since I'm horrible at arithmetic. My algebra students always tease me about that. 2.5 times 12 is 30. And that's 30 watts. So B is our answer. Okay. How much current is required to deliver 120 watts at a voltage of 12 volts and they're asking about the current? Well, what we have, at least I have memorized P equals IE. This is solved for power. I need this solved for current because they're asking for current. So to get current on one side of the equal sign and everything else on the other, I'm going to divide both sides by E. E over E cancels to 1. 1 times I is just I. So I then is equal to the power divided by the voltage. So let's fill that in. We have a power of 120 and we have 12 volts. This goes in 10 times. So we will have 10 amps of current. Here's where you need just the tiniest little bit of algebra to rearrange these letters, unless you memorize the 3 formulas. And actually there's like 5 or 6 for power. So keep that in mind. All right. So what formula is used to calculate current in a circuit? And they're giving us Ohm's law. And I always remember that is voltage is equal to the current times the resistance, or V if you're used to using V. They want to know for current. So we need to rearrange this for current. And they have all 3 guesses here. Let's make sure. I want current by itself. So if I divide both sides, remember in algebra, you need to do whatever you do to one side of the equation, you must do to the other. So if I divide by R, that causes that to cancel, leaving I by itself, and this also has to be divided by R. So the answer then is I is equal to E over R, and that happens to be answer B. Okay. We might run a minute over time, but I want to finish this first 10. I've been doing more talking here than working. All right, so what formula is used to calculate voltage in a circuit? Well, that's the one we memorized straight off. So E is equal to the current times the resistance. And that's the very first one, which is A. Okay, and then lastly, what formula is used to calculate resistance in a circuit? Same idea. I always start with the same thing. It's the only one I have memorized. E equals I times R. I need this equation solved for R. What's being done to R? It's being multiplied by I. What's the opposite of multiplying? It's dividing. So I will divide both sides by I. That leaves R by itself. So the formula used to calculate resistance is R equals E over I. R equals E over I is the second one. All right, there we are. There's the second 10. I'll see you in the next video for the final 10.